ーっと、はい、お疲れ様です。フリックです。まあ、独り言配信やっていこうかなって思いますと。で、最近作ってるものがあって、なんだったっけな。なんか、これ作りたいみたいな。これか。このスカイウェイっていうサービスがあるんですけれども、こいつ作ってみたいなっていうのがあって、で、まあやってますと。で、前回、エリクサーフェニックスをギガリクサーに、アップロードしようかなっていう初歩的なところをやろうとしたらそこで詰まってしまったので、まずはそこの、解明からやっていこうかなって思います。なんか Git から弾かれてしまってるのでなんでかなっていうのを調べます。はい。じゃあやっていきましょうか。まあとりあえず状態の再現ですね。まあUbuntu の、WSL2 っていうものを使ってから WSL2 の、環境でやっていきますと。で、その中のまあ、自分ユーザーネーム階層の下でプロジェクトを作っていきます。まあこれでいいか。まずはフェニックスの環境を作ります。ちょっと短い。あ、下に行き過ぎた。ミックスフェニックスドットニュー新しく作るよ。プロジェクト名はWebRTC をやっていきたい。小文字じゃないといけない。ちょっとでノンエクトサーバーはとりあえず いりませんと。まあ、必要に応じて後で追加すればいいかなって思います。うん。配信されてんのかな。まあいいや。ちらり。あれでそうですね。ミックスデプスなんかいつもより遅い気がする。うん。まあなんで自分がこのスカイウェイやりたいかって言ったら、なんだろうな、 ネットワークでチャットができるっていう仕組みなんですね、これ。で、ウェブの、なんだろう。まあ、ビデオ会議とか、音声通話とか、昔は電話回線とかを使って、まあ、電話をやってたんですが、今は、インターネットだけでできますよ、と。うん。で、それができると、いろんな、まあ、ゲームであったり、なんだろう、ディスコードとか、スラックとか、これも、音声通話とか、ビデオ会議とかできる機能なので、そういったものに派生しやすいんですね。なので、このサーバーを作っておくっていうメリットは、すごくありますと。なので、この辺見て、ターンサーバーと、STUN サーバーと、TURN サーバーっていうのをまずP2P のサーバーですね。こいつを理解してから、こんな感じで、まあサーバーで、このクライアントをつなげてあげて、クライアント同士で、通信してあげるっていうのをやってみたいなと思ってます。はい。で、そうこう言ってるうちに、できましたね。じゃプロジェクトに入っていきましょう。CD の。はい。このミックス、フェニックスドットサーバー、もうこれだけで、フェニックスのサーバーがローカルで立ちますよと。ローカルは4000番ですね。おっと。あ、今立ち上がりましたね。お、本当に？なんかネットワーク遅くない？いや、ローカルだからそんなこともないとは思うけど、なんか遅い。まあいいや。まあ、こんな感じで、Web フレームワークは簡単に、作れますよと。はい。まあ、そんなことはもうどうでもよくて、このテンプレートをとりあえず、ギガリクサっていう本番環境に上げていきたいと思いますと。で、本番環境への上げ方は、まずは Git 作りましょうと。Git init。まず自分の Git、ここが足んなかったのかな。ユーザー E メール、はい。で、Git init。これで、まあ、イニシャライズ Git ができて、そこから、ギガリクサーの新規プロジェクトを作成しますよのギガリクサーの、コマンドはなさそうだね。ちょっと。ギガリクサーの、デプロイ。小賀さんのやつ見て。git init git add init commit init をやったからとりあえずは git add でまあ全部対象に、git でコミットしますと。 はい、コミットされましたよ。で、ギガリクサ CLI のインストール、これもしかしてやってないなんて、やってなくはないような気がするんだけどな。pip3 で、init ギガリクサユーズっていうのはギガリクサヘルプっていうのを、なるほど、ギガリクサがない。pip3 が、嘘。ギガリクサそれは嘘でしょう。よっ。いや、WSL のやつで作ってないからかな。ターミナル開いて、パワーシェルじゃなくて、Ubuntu の、今ホームにいるから、cd のホームアンダーバー、の、フェニックスの、RTC かなRTC02 ないですよって言われてる。フリーの CD コメスラ、ラバーフェニックスの中に入ってからの、どこだっけ WebRTC の2アンダーバー02入りました。この中で、ギガリクサーバージョン。なるほどね。通常のコマンドプロンプトじゃダメ。いや、それはそう。なんか分かってきたぞ。最初からここで作成しとかないといけなかったんじゃないかな。だから、まあまあ、やってしまったからには仕方なくて、WebRTC02 のギガリクサーのバージョンを知りたい。ヘルプ出るかなで、出るよね。なるほど、なるほど。そっかそっか。だから、このコマンドプロンプトはどこで見てきたかっていうと、Windows 上から Linux を見てたから、表示されなかっただけで、きちんと Linux 上の、ターミナルであれば見ることができますよと。はい。でだ。こっからギガリクサーへのログイン。ログインします。E メール。パスワード。で、ログインしましたよ。ギガレクサーコマンド叩けるようになりましたよ。アカウントはちょっと、 見せるのはダメで、クリエイトしましょう。で、このギガリクサークリエイトだけだと適当な名前が割り振られるだけなので、なんか、名前を決めたいですよと。これかな。名前を決めるためには Git の Git バージョン、ログインしますよ。ピアチレさんの記事ですね。ローカルフェニックスのイクトで作成しますよ。ブラウザ立ち上がりますね。ギガリクサーで、バージョンを指定しない限りで5、はい。なので、作成してくださいと。いうのは、まあ、また後日をも書いてある。Git のメールアドレスを指定します。イニットします。ログインします。あった。ギガリクサー、Git レポート APP、なんだこれは。以下コマンドで、現在、フェニックスプロジェクトフォルダ、APP リポジトリ、はい。リリースコント、プッシュマスター、アプリ名を作りたいから、ギガレクサークリエイトっていうものを見たい。はいはいはい。なんか、最初からアプリ名って決められるんだね。だから、ギガリクサーの、アプリでクリエイト、最初から、クリエイトしといて、WebRTC、これで多分アンダーバー使えないよっていうので、はい。ハイフンも使えないよ。ドットも使えないよ。まあ、しゃあない。基本的には、Google クラウド、Amazon Web サービス。Amazon Web サービスの方が、なんか最近流行りの 5G に対応するから速くなるっていう噂があるんですが、まあ、この4種類どれかでいいような気がしますよと。はい。小文字じゃないとダメですよ。はい。いや。はい。じゃあちょっとテスト用の、クライアントクリエイトしましたよと。はい。で、作成しますよ。エリクサーバージョン確認します。コンフィグ作成します。なるほど。ギガレクサにログインします。Git と、 ギガリクサーコマンドで、Git のリモートをアプリ名にします。アプリ名は、WebRTC テストにしました。で、セット Git リポートギガリクサーで、これで、連携されましたよと。で、リリースします。今、コミットニューまではやりました。Git プッシュします。Git プッシュ、ギガリクサーマスターに。OK。もしフェイルド URL などのようなF ってなりますね。Git プッシュ F でマスターに上げてください。それでもエラーが干渉してなるほど。エリクサーのバージョンが新しすぎて、ギガリクサーの、だから、はい。なるほど。まあ、確かにちょっと自分、エリクサーのバージョン最新にしすぎて、なんだろう。こいつが出るよって。さすがだな。解決してしまった。だから、まずは、エクトで。
コネクルさん、おはようございます。
コネクルさん、おはようございます。今、まあ、コーディングやってて、エリクサーで WebRTC やってみようかなっていうので、それに挑戦してます。よいしょ。コネクルさんは、はじめましてですよね多分。エリクサーのバージョンと、RAN のバージョンを指定してあげて、Node.js のバージョンも、指定してあげますよと。で、指定してあげたら、まだまだ。どれだったっけな。データベースは用意しなくてまだ用意しなくてよくて、ES ビルドって最近に変わったので ES ビルド用のビルド。
コネクルさん、リファレンス読み合わせ配信とか覗いたりしてました。
なるほど。まあ、あれですもんね。だいたい、なんだろう、ドキュメントが正なので、ドキュメントを読んで、ここ合ってるよねとか、なんか。
コネクルさん、プログラム派全然わからないです。
まあまあ、いいんです。プログラムが動けば。なんだろう、コンピューターはこう、言われたことを実行するので、なんだろう、こう命令すればこう実行するよみたいなのを書いてあげるのがプログラマーの仕事だと思ってます。よいしょ。ちょっと遅延はすごく大きいので、レスポンスに3分は言い過ぎですが、 1分ぐらいかかっちゃいます。よし、コミットしましょうと。OK。で、プッシュしてあげて、だから、バージョンかな。エリクサーのバージョンが新しくすぎて、ギガレクサー未対応の可能性、上記ビルドパックパッケージ、だって、だから、エリクサーのバージョン、あ、そっか、自分のエリクサーのバージョンを確認しないといけないのかな。で、エリクサーは 1.13 高すぎかな。ここに書かれてるの 1.10 だもんな。だから、ビルドパークのエリクサー 1.1 と 2.2。キャッシュをクリアするのと、ノードのバージョン 21.3、ノップのバージョンもなんかあるので、クリアして、再プッシュ。コミット、フィックス、はい。で、マスターにプッシュ。これでいけないかな。ダメって言われた。リジェクトされる。エラー failed to push someone else to Git の URL というようなエラーが出てしまう場合は、それでもエラーが解消しない場合は、ギガレクサーのビルドパックの、エリクサーのバージョンを下げた上で再プッシュ。ギガレクサー側でコンパイルが自動、 アップできてるものを確認しよう。多分これ。13.0。逆にバージョンが古すぎた。まずは、コミットしました。アーランのバージョンが古すぎた。なぜ？合わせたけど、うん。いけた？あ、いけたね。なるほど。だから、ノードのバージョンがダメだっただけか。まあ、バージョン違いはよくあるよね。いけた。最低限。オッケーオッケー、動いてる。ビルドが走ってます。はい、OK です。で、オープンしてみましょう。まあ、データベースは、用意しなくていいので、マスター、なるほど。用意できてますかのステータスで、マイグレーション、データベースないですよ。はい。ログ、なんとなく。ログが見えますよ。はい。まだ、ないですよ。 こんだけ短い、名前になってくれるんだ。だから、そうですね。今、アプリのこういう WebRTC っていうのを作りました。で、もう多分いける？キャッシュクリアしないといけない？404エラーがしてる。名前サイズレプリカクラウド、領域スタッフ、名前コア。はいはいはい。再起開ける。だから、だから、やっぱり、データベースを作らないといけないのかな。データベースの作り方、データベース用意しましょうよ。あ、ほい。ほい。作られました。確かめましょう。ありますよ。作られていることを確認しましょう。ありますね。で、これはデータベースのことだから、まあ別によくて、行きましたね。この、本番環境で、エリクサーフェニックスのウェルカムトゥフェニックスも何も手を加えてないものが、出ましたよと。で、本番環境の実装はできたので、こっからですね、ちょっと脱線したいことがあって、こいつを GitHub に連携できないのかなっていうのがすごくあって、さあ、エリクサフェニックスアプリありますね。GitHub、アクションズで、違うな。いうのはできないのかな。うん。 なるほど。うん。Git と GitHub。なるほどね。NGET もそう、プロジェクト。まだこう、まだGit、あれだな。まあいいか。ギガレクサコミットしました。コミットできましたよ。で、この開発環境でやります。次にやりたいことは、だから、チャンネルチャンネルギガレクサーのソースツリーとかって見れるのかな。よっ。Git のリポジトリです。参照は、Windows。いけたいけた。なるほどね。 だから次の問題はチャンネルを追加したいかな。フェニックスチャンネル。まずはチャットアプリケーションを作る。昨今の Web アプリケーション、クライアントサーバー常時接続、メッセージ通信することが求められてきますと。リアルタイム Web アプリケーションと呼ばれたりします。このアプリケーションには以下の特徴があります。クライアントサーバー常時接続、クライアントからではサーバー接続から通信速度が多い、このような状況。ソケットっていうのが必要されてきました。特徴の HTTP に対する WebSocket の優位点は、Web 双方で通信する仕組みと、データ、それぞれ必要な情報を送ることができる。チャンネルっていうのは、フェニックスがサポートしているリアルタイム通信の機能ですと、送信者がトピックに関するメッセージをブロードキャスト、受信者はトピックを購読してメッセージを実践する、デフォルトでは WebSocket プロトコルを使う、接続しているクライアントへ、チャンネルの機能は、これはこのチャンネルのここに書いてある、ドキュメントに書いてあることですね。はい、サンプル WebSocket を使ったチャットアプリケーション。これってなんかこの辺に書いてありそう。チャンネル。概要。このガイドは入門ガイドを読み、フェニックスアプリケーションを起動して実行していることを前提としています。チャンネルはフェニックスのエキサイティングな部分であり、接続されている何百万ものクライアントのソフトをリアルタイム通信を可能にします。考えられている使用例は次の通りです。メッセージアプリのチャットルームと API、ゴールが決められた、地震が来ているなどの最新ニュース、通常の電車スラック、またはレースの参加者を追従するマルチプレイヤーゲームイベント、センサーの監視と照明の整合、ページの CSS またはステパースクリプトが変更されたことをブラウザに通知する。概念的にはチャンネルは非常に単純ですと。まずクライアントは WebSocket などのトランスポートを使用してサーバーに接続します。接続すると一つ以上のトピックに参加します。例えば、パブリックチャットルームを、対話するにはクライアントと呼ばれるトピックに参加し、パブリックチャット ID7 の製品から最新を受信するにはトピックに参加する必要がありますと。クライアントは参加したトピックにメッセージをプッシュしたり、クライアントからメッセージを受信したりできます。逆にチャンネルサーバーに接続されているクライアントからメッセージを受信し、それらのメッセージをプッシュすることもできます。サーバーは特定のトピックに、サブスクライブしているすべてのクライアントにメッセージをブロードキャストしていきます。これ。トランスポートチャンネル、フィッシュハブ、ソケットコネクト、トランスポート、ディスパッチ、チャンネルズソケット get.json トピックで、サブ。アプリケーションが複数のノードコンピューター実施されている場合でも、ブロードキャストが機能します。つまり、2つのクライアントのソケットが異なるアプリケーションノードに接続されていて、同じトピックのサブでプライされている両方のクライアントがブロードキャストにされたメッセージで受信します。これは内部の、パブサブメカニズムのおかげで可能です。チャンネルはブラウザネイティブアプリスマートウォッチの、組み込みデバイスが他ネットワークに接続できるその他あらゆる種類のクライアントをサポートできます。クライアントに必要な、適切なライブラリーは以下参照してください。各チャンネルトランスポート一つ利用して実施します。現在それは Web ソケットまたは、ロングコーディングのいずれかですが、将来的に他のトランスポートが追加される可能です。ステートレスで接続のためチャンネル寿命をサポートしています。軽量の、ビームプロセスに支えられており、並行して動作し、独自の、状態を維持します。このアーキテクチャは適切に拡張できます。フェニックスチャンネルは一つのボックスに妥当性の遅延で、数百万のサブスクライバーをサポートし、1秒あたり数十万のメッセージを渡すことができます。また、クラスターにノードを追加することで、その容量を増やすことができますと。チャンネルは、クライアントの観点から簡単に使用できますが、サーバーのクラスターを介してクライアントにメッセージをルーティングするためのコンポーネントがいくつかあります。それらを見ていきましょう。概要、通信を開始するには、クライアントはトランスポート、Web ソケットやポーリングなどを使用してノード、に接続し、その、単一のネットワークを接続し、使用して1つ以上のチャンネルに参加します。クライアントごと、トピック1つにチャンネルサーバー計量プロセスを作成されます。各チャンネルを浮遊し、フェニックスドットソケットはその内部に必要な状況を維持できますと。接続は確立されると、クライアントから各着信メッセージはそのトピックに基づいて、新しいチャンネルサーバーにルーティンされます。チャンネルサーバーがメッセージをブロードキャストを要求すると、そのメッセージはローカルの、パブサブに発送され、ローカルのパブサブはローカルに接続され、これですな。トランスポート、チャンネルルート。開始するためのソケットジェネレーター、まずはこれかな。ミックスで、フェニックスジェン、ソケットユーザーを追加しますよと。なるほど。 お、おう、なるほど。過去の状況は見れないけれど、ここで、ふんふんふん。えーっと、簡単なチャットの例、フェニックスフレームワークで構築。新しいフェニックスのアプリケーションを、開催するために次のことを行うことがあります。このクローンしたら、依存する関係を、デプスゲットする。なるほど。オプションの、npm 依存関係をインストールして、JS パスをカスタマイズする。のをインストール。で、フェニックスルーターを起動します。サーバー。ライブデモは、ここですと。ヘロクだね。さっき見てたのヘロク？JavaScript のコードで、Phoenix から、ソケットクラス CPP、クラス作って、ソケットロバー、ソケット、チャンネル、using IG123、 ソケットオンオープンエラークローズ、チャンネルソケット、JSON、インポートオフ、はい。エンドポイント、チャットエンドポイント do は、ライブラリーチャットエンドポイント exe、ソケットチャンネルズユーザーソケットの、エリクサーに、各、チャンネルはどこ？ファイル、チャンネルって書いたら違うものが出てきそうだけどな。
Technologies allows the school to focus on what the IT systems deliver to learners.
Phoenix is the most popular framework for web development in Elixir. And one of its most exciting features is the ability to add real-time functionality, which we can do with channels. In this episode, let's see how we can build a simple chat application with Phoenix using WebSockets. Let's start this project from the ground up. So the first thing we'll need is a fresh Phoenix application. Let's create a new one with the very unoriginal name chat. And we'll install the dependencies. Then we'll cd into the chat directory and create our database with mix ecto create. Then let's start our application to make sure everything looks good. And great, we see the familiar Welcome to Phoenix page. Now that we know everything is working, let's get started on building our chat room. We'll need to generate a new channel. Phoenix provides a generator we can use. We'll just need to give it a name. Let's play with the idea of a chat room and call ours water cooler. It creates a water cooler channel module. We'll look at it in a minute, but first let's add our channel to the user socket handler. We'll send any events with the water cooler topic to our new water cooler channel. The asterisk is a wildcard, catching any events coming to our water cooler topic, regardless of the subtopic, and sending them to our water cooler channel. With that updated, let's open the water cooler channel module that we generated, and we see that it has a join callback that will handle events for the water cooler lobby topic. In the example that Phoenix creates, it gives us an authorize function that will always return true. It's a nice guidestone for where we could start to put custom authorization logic. In our example, we won't do any authorization, so let's remove this logic and have it always return the OK tuple with our socket. And since we won't be using the payload, we can ignore that with the underscore. The handle and ping function we won't use for this example, so let's remove it. The handle and shout function is in charge of broadcasting any chat events to everyone that's joined our channel from our client.
ちょっと荷物が来たので。はい。 違った。
And we'll remove the authorized function, since we removed the authorization logic in the join callback. Now let's open our socket.js, and we see some code has already been populated that imports and connects our socket to the socket path in our endpoint module, which is then handled by our user socket. Our default code also shows how we can join channels with a topic. The topic we defined in our water cooler channel is water cooler lobby, so let's update that here. It then logs out a message to our browser's console, letting us know if we've joined successfully or not. Then let's open our app.js and import our socket. Now let's go to the command line and start our server. Let's give it a shot. We'll open our browser, and in the console, we see our success message is printed. Now that we're joining successfully, let's create a chat window and a form we'll use to post messages with. But let's first customize our site a bit. We'll remove the Phoenix CSS style sheet. And in the app CSS, I'll paste in some custom CSS, which is available in the linked GitHub repo. And we'll open our app template. And let's remove the Phoenix logo. And then in our page's index template, we'll paste in the chat window and a form that will have our username and message fields. Now let's open the browser and see what it looks like. We see our chat box and our form. Now let's add some JavaScript to get our chat working so that when we post a message, it's displayed. Back in our editor, we'll create a new file in assets.js named watercooler.js. And we'll define our water cooler object. Then we'll create a function in init that will take our socket. And with our socket, we'll join the channel with our water cooler lobby topic. Now that we've joined our channel, we need to send and receive events. Let's create a new function, listen for chats, that will take our channel, and I'll paste in the code for sending events, but let's walk through this. We're getting our chat form with the ID chat form, and then listening for when it's submitted. When the form is submitted, we're preventing any further action with prevent default. Then we're getting the username from the form and the message from the form. Then we're calling channel push with shout and a payload of our username and our message. This will send our event to the server where it will be picked up by our water cooler channel. Then we're setting the username and message fields on our form. Now that we're set up to send events, we need to receive them. We'll use channel on to subscribe to channel events, matching on shout. Then we'll get our chat box and create a new message block. Then we'll build up our message by getting the name and message from the received payload. We'll then append that message to our chat box. Now let's open our app.js and we'll import water cooler. Then we'll call init, passing in our socket to use. And if we go back to the browser and try typing a message, we see our message is received and broadcasted out to everyone that's joined. And let's try sending a message back. And great, that works too. This is great, but when we refresh the page, our chat disappears. This is because nothing's being persisted. We'll fix that by saving our chats to the database. Let's have Phoenix do the heavy lifting for us here and use the context generator to build out the modules and database migration that we'll need. We'll go to the command line and stop the server, and let's create a new context chats. Our echo schema module will be message, and our table name will be messages with the name column that's a string and a body column that's a text. Then we'll migrate our database, and let's take a quick look at the message module that was created. We see our schema with our body and name fields and our change set. Then let's open the chats context, and it's been populated with some functions to save and retrieve our messages. Great, now we need to save our messages when someone posts one in the chat. Let's do that in our channel. We'll open our water cooler channel module, then let's alias our chat's context, and in our handle in function, we'll save the message before it's broadcasted out. While we could make this asynchronous, let's keep it simple for the purpose of this episode. Now that we're saving our messages, we need to load any existing ones into the chat. Let's open our page controller, and we'll alias our chat's context module. Then let's get all of our messages, and we'll pass them in our assigns. Now we can open our index template and render any messages that were returned in our chat box. Then let's restart our server and go back to the browser and post some messages into our chat. And let's do a quick check of the database. And great, we see our messages are there. And if we go back to our chat and refresh the page, we see our existing messages are loaded. That's it for this episode. Thanks for watching and happy coding.
Family is 簡単に言うと自分が書いた英語を分かりやすく、あと文法的。
なるほどね。チャット。
Hey, David Ralphoff here. Hope you're having a good day. Just wanted to do a quick video on Phoenix channels. It's kind of one of the, I would say, one of the killer features, I guess, in Phoenix, and it's something you might have heard about. It's a pretty neat tool, so I would just wanted to kind of walk you through an example of what it does, and then also, you know, kind of show you some of the cool use cases for it, or common use cases for it, and then maybe some even unexpected ones. So if you think about something kind of like a traditional chat application, or even like a collaborative document editing application like Google Docs or something, where you can see multiple people doing things at the same time, that's kind of the sweet spot for Phoenix channels. Essentially what it does is it lets you set up a kind of like a pub sub or publisher and subscriber pattern over WebSockets. So essentially you can say, hey, I've got this topic, and if anybody's interested in this topic, they can listen for events that happen on this topic. And so say, for example, if somebody joined a chat room, they would say, you know, I'm interested in this topic about this specific chat room. And when I post a message, I want to broadcast that up to the server. And that'd be done over WebSockets with Phoenix channels. And then when it hits the server can say, oh yeah, I got something on this new topic. Anybody who subscribed, I'm just going to send that out to them, and they can pick it up. So, you know, so basically as soon as you enter your message, that's going to go up to the server, and that's going to go out to all the subscribers. And the examples that you'll typically see Chris McCord do, who's you know, built Phoenix, or been the main force behind Phoenix. He'll do a lot of stuff like chat applications and collaborative docs. And because Elixir or Erlang is so fast underneath it, it's super impressive. You can have, like, you know, tens of thousands of people join without any problems. And the way that they've written it, I guess kind of the other part of the secret sauce is it's just fast, and it's really easy to put into place. So it's a very minimal amount of JavaScript that you have to write. And the code on the Elixir side is also pretty minimal. So enough talking about it. I'll just kind of show you something I've used it for here, just as an example. So when this is a little charting app I have that just initially it starts with random data from the client side just to render the chart. But every time this randomize button gets clicked here, it's actually on the channel saying, hey, I want to randomize this data, and then it sends it up to the server. The server is going to randomize it. You're going to get it back. And it's super fast. Like, it's like microseconds, not... actually, it's like, yeah, I think sub 1 millisecond. So it's super fast. and you can see just like it looks like it's all happening in the client side, right? It's just that fast. And what's cool is I've even done this with like really big data sets over like 100 years, and it's still pretty much this fast. You can notice a very slight delay when you get the data sets big enough, but I'm not sure if that's on the Elixir Phoenix side or if that's just the the browser trying to render that much data. So I mean, this on its own isn't super impressive. It's it's pretty cool. It's a nice trick. What makes it really cool is when you see that it's actually synchronizing. So here's another tab or window, but it could really be any client. And you can see here, it's got the exact same thing. And if I click this randomize button, both of these are going to change. So I'll hit this, and you can see it's all updating, and it's all super, super fast, right? And it's pretty cool. Like if you think of any application you have where you want to make sure that all your clients stay in sync, then it's a really good tool for doing something like that. And there's use cases I keep learning about that are even a little initially seem a little surprising, but they actually make a lot of sense. And I'm kind of feeling like a channels and a pub sub arrangement maybe is almost a better default than what we're used to, which is not having any of that. And the reason I say that is if you think about if you think about using like multiple browsers or tabs, often you really do want your experience to stay in sync across those. So a really interesting one I heard about recently was somebody was building a shopping cart app, and they built it so that as you go through, you add things to your cart and you can change the quantities, and then when you're ready to check out, you can go on to checkout. Just kind of all the normal stuff you would have with a shopping cart. But what was really cool was they did it all using channels, and I guess they were pretty new to Elixir and Phoenix, and it didn't even occur to them that in a shopping experience where you have multiple windows or multiple tabs open, that all of your shopping cart information is going to stay in sync and up to date across all of those. So I think this is probably common for a lot of people. Like if you're shopping and maybe you're comparing a bunch of items or something and you have a bunch of tabs open, as you add an item from one tab, when you switch over to another tab, it's going to be there and your total is going to be updated already, and you don't have to do anything special. So I really do think there's a lot of great use cases for Phoenix and channels, especially with the speed that it has. The speed lends itself well to doing any kind of like collaborative or real-time applications where you have multiple users or multiple clients, even if it's the same person. But I also do think for even some of these slower applications, these more traditional things like shopping experiences, anything that has like an ordering flow or a process you're going through, being able to preserve that across all of your tabs or all your browsers or whatever it is. Maybe I haven't experimented with this, but maybe it can be done across mobile and desktop as well. It just seems like a really kind of like a no-brainer to me. So anyway, I just wanted to kind of walk you through what Phoenix Channels is. I'd encourage you, if you're playing around with Elixir Phoenix already, to just try using it. It's pretty easy to get going. And yeah, thanks for watching. If you're interested in seeing more videos like this, hit subscribe and hit the notification bell to make sure you're notified when new videos come out. Also hit that like button, really helps me out, and I'll see you in the next one.
。お。ふんふんふん。うん。ふんふんふん。ふんふん。 うんうんうん。シグナリング。うん。うんうんうん。JavaScript か。ローカルビデオ、リモートビデオ、テキスト4、ああ。なるほどね、なるほどね、理解してきたぞ。だから、このシグナリングサーバーっていうのが、音声とか通信するやつなので、あるじゃんね、さすが。 うんうんうん。うんうんうん。JSON のパーサーがある。いいな。 おー、再検討か。最新の JavaScript と Elixir Phoenix を使用したビデオチャットアプリケーションの再検討。以前の投稿では、WebRTC と Elixir を使用した簡単なビデオチャットの実装について説明しました。なるほど。フェニックス、WebRTC のリベースド、再検討ですね。これによりプロジェクトディレクトリが、作成され、Webpack、そう、これが廃止されたからね。で、フロントエンドがセットアップされますと、これによりビデオチャットのシンプルなバージョンの作成がはるかに簡単になります。プロジェクトはかなりうまくブーストラップされているので、コントローラーの作成とインデックスのページで応答の処理をスキップできます。代わりに予想されるトラフィックに合わせて、チャンネルを設定することに直接、ジャンプできます。これはチャンネルセットアップのコメントを削除し、ハンドラーを待機するトピックに変更することを意味します。やっぱりチャンネルはいるよね。ということは、最初にこっちから勉強した方がいいかな。2005年。7年前か。これは最近だよね。7年前から3年前になってる。はい。ウェブのコントローラーズ、コールコントローラー、昔すぎてなくなってる可能性すらあるな。 Build a video chat apply in Phoenix Live View. During this global pandemic, online video call has become essential to the way we work. Millions of workers and now demonstrated to hopping on Coldway were current to passing out the way, which the town in person Zoom has shown. Mm-hmm.
「
うん。
So I'm going to present my talk, which is like building video chat with Elixir and Phoenix. I'm Anil, and I'm from India, and so I like drinking coffee. I like traveling. I like Japan as a country. I'm interested to know more stuff from there. I like listening to music. So last year, I was working on a consulting assignment, and my client asked me to build a video chat application. And at the same time, I was doing some Elixir work. Video chat was a nice use case for Elixir and Phoenix. So I initially I experimented with Elixir and Phoenix, and then we decided to build this application with Elixir and Phoenix. So the application name is scatter.me. So let's see a quick demo of that.
We are all connected these days, even the things around us.
So do you see this? Okay. So this is Scatter. So it's a video chat application, and this is public version of Scatter. So we also have a other version where we have sign up and sign in. But here you can go and directly create a room by entering a room name. So I can create room like this. So I have created room, and now I can join the room like with the join button. So I can share this URL with my friend, and he can also join the same video chat room. So this is, so you can see I'm part of the video chat now. So yeah. So this was Scatter, and my client also knew Erlang, so he allowed me to use Elixir and Phoenix and all. So let's see how a video chat works. So video chat is typically built with WebRTC these days, and let's see how WebRTC video chat works. So typically there is a single computer, and with single computer, what we do is that we have some chat app. So we open that, and then we connect with some other computer, and then with that video chat application, we can send our data to other computer, and the other computer sends us data. So with WebRTC, we can do that. We can have WebRTC JS where we can connect the other computer, and then we can start sending video data with UDP streams. So this is like between two computers, and then we can add another computer, and then all three computers can send video data, which is like UDP data, to each other, and then video chat session starts between them. So this happens peer-to-peer. So video data is transferred from your computer to other computer, peer-to-peer. So there is no server required. So what if fourth user joins the video chat application? So if fourth user joins, so all of them start sending video data to every other computer. Like my computer will send my video data to other computer, and that's how a video chat application works, right? I can see 3 of my friends in a video chat, and then we have video chat running. And with WebRTC, we have peer-to-peer video chat working. So how to communicate, right? So when I connect with my friend's computer, I have to know his IP address, right? From a JS application, I have to connect to his computer IP address. So we could do that. We could write JS applications and hardcode IP addresses, and we can initiate video chat. But typically, this is not done. Like, this is not practical. So we don't hardcode IP addresses in the JS client. So we use some kind of a server, intermediate server.
Signal
we call
serverがい
it as
る
a signaling
よね。
server. So
はいはいはい。
signaling server is nothing but a broadcast server.
を
So we could
Phoenixで
use something like
作
Node.js,
れ
or
ま
we
す。
could use some other technology also. In my case, I use Phoenix as a signaling server, and so it's just a Phoenix application running with some port, and then all other computers where JS client is there connect to this particular IP with the port, or it can be a domain name. And once they all connect, so with WebRTC, every computer sends a WebRTC offer. So this offer is sent to Phoenix server, which is signaling server, and that offer is broadcasted to other computers with the signaling server. So once the offer is broadcasted to other computers can accept that offer, and once this handshake is complete, offer and answer handshake, then WebRTC communication starts. And WebRTC communication doesn't happen via Phoenix server. It happens direct peer-to-peer. So video chat is always peer-to-peer with WebRTC. So we now see how I use a signaling server. So Phoenix as a signaling server, where from clients I send offers to Phoenix, and Phoenix is used to broadcast the offers. And the clients, JS clients, can send an answer, which is also sent to the Phoenix server, and then handshake gets completed and a video chat session gets established. So WebRTC peer-to-peer is actually not scalable. Let's see how. So let's say like there are 5 computers now. So we use Phoenix as a signaling server. We like all computers send offered, and they receive also answers from other computers, and then video chat was working. But what we see is that video data gets transferred peer-to-peer. So from my computer, I am sending my video data to 4 other computers. So if I have limited bandwidth, right? If I have like 10 Mbps connection, and if 1 Mbps is taken for sending my video data to other computers, other bandwidth is also used to send the video data to other computers. And I am also receiving the video data from other computers. So WebRTC peer-to-peer is definitely not scalable. So we need some kind of solution. So this is the problem. So if I add more computers, more uplink streams are required, and because of bandwidth issues, we may not be able to scale it up. So this is the problem. So what is the solution? So solution is to use some kind of a gateway server. We call it as WebRTC gateway server. And with this WebRTC gateway server, we could solve this problem. Let's see how. So we have Phoenix as a signaling server. All computers send offers to the Phoenix, and these offers is sent to this WebRTC gateway server. So like other computers, WebRTC gateway server is also another computer, where what we do is that we send offers by these computers to this WebRTC gateway servers, and this WebRTC gateway servers send answers, and the handshake gets established between these computers and WebRTC gateway server. And WebRTC gateway server takes responsibility of like getting the stream of other computers and sending the multiple streams to other computers in a video chat. So in this case, like there are 3 computers connected to video chat, and all computers send an offer to the Phoenix signaling server, and then this offer is sent to WebRTC gateway server. This handshake gets established, and my stream is only sent to the WebRTC gateway server. Other computers are the uplink stream is only sent to the WebRTC gateway server, and the downlink is sent by WebRTC gateway server. So this is how we can solve the problem of like WebRTC peer-to-peer. So in this case, you can see there is only one uplink UDP stream, and we can receive multiple downlink UDP streams by introducing WebRTC gateway server. So this is how typically in production we have WebRTC gateway servers. So so this was about WebRTC gateway server. So why I use Elixir and Phoenix? So basically. Elixir offers this awesome OT features such as Gen server.
by Elixir Phoenix。エリクサーは、OTP、ファスター、OTP がすごく速いです。ジェンサーバーで、ジェンイベント、ジェンステージと、サブサーブ、
or agent, Gen event, these are also WebRTC gateway servers. So so this was about WebRTC gateway server. So why I use Elixir and Phoenix? So basically, Elixir offers this awesome OT features such as Gen server, agent, Gen event, Gen stage, supervisor, and then Phoenix offers me like channels. So this is real time, right? My video chat is real time. So I also have chat, like text chat, and lots of things are real time. So I need something like channels. So I could have used Node.js, but Phoenix is more powerful because of channels, and Phoenix also offers me other web app basics such as authentication and lots of libraries and good ecosystem. So I use Elixir and Phoenix because of that. And then with Elixir, we get actor model. We have like a battle-tested OTP abstraction, so we know that these will work fine. Then Elixir also, like the Phoenix framework also offers me a good fan out. Like I can accept n number of connections, and then I can serve those, and then fault tolerant. So this is something like in Erlang or Elixir, we have let it crash philosophy. So we can architect our applications to be fault tolerant, and also it's soft real time. So it fit my needs really well. So let's see the WebRTC gateway server that I have used in my application. So it's a Janus WebRTC gateway server, and it's an open source WebRTC gateway server. So So this is website of Janus WebRTC Gateway Server. So this is open source. It's built with C. It has small footprint, and it also supports plugins. So there are pluggable modules which we can write or we can use, like existing plugins are there. So this is list of WebRTC like this Janus WebRTC Gateway Server plugins.
そこにあるの。
In my application, I have used a plugin called
ち
Video
ょっ
Room.
と待って。
Our application authentication and lots of libraries and good ecosystem. So I use Elixir and Phoenix because of that. And then with Elixir we get actor model. We have like a battle tested OTP abstraction, so we know that these will work fine. Then Elixir also like the Phoenix framework also offers me a good fan out. Like I can accept n number of connections, and then I can serve those, and then fault tolerant. So this is something like in Erlang or Elixir, we have let it crash philosophy. So we can architect our applications to be fault tolerant, and also it's soft real time. So it fit my needs really well. So let's see the WebRTC Gateway Server that I have used in my application. So it's a Janus WebRTC Gateway Server, and it's an open source WebRTC Gateway Server. So so this is website of Janus WebRTC Gateway Server. So this is open source.
オープンソースか。OK です。
It's built with C. It has small footprint, and it also supports plugins. So there are pluggable modules which we can write or we can use, like existing plugins are there. So this is list of WebRTC like this Janus WebRTC Gateway Server plugins. And in my application, I have used a plugin called Video Room. But there are other plugins such as echo test, like then streaming, like voice call, text room. So in typical video chat world, like there are different kinds of services available. But in my case, I just needed video chat. So I use this Video Room plugin. And so Janus is a C-based WebRTC gateway server, and it has so it's a server. So it has different kinds of APIs. It supports like RESTful APIs, WebSockets APIs, RabbitMQ, MQTT, and Unix sockets. So I wanted to use WebSockets, but there was a bug that time. I faced some issues. So I use RESTful web APIs in my application. So let's see Janus RESTful APIs, like what are those? So it's simple to understand. So Janus has this endpoint called /Janus. So what we do is that we create a session on Janus by sending a post request to /Janus. And then once we create a Janus session, we get a session ID. And on that session ID, we can send again post request to attach a plugin. So Once we attach a plugin, we can start a video room. So in my case, I use video room plugin, so I can start my video room. And so this is about creating a video room on Janus. But in video chat application, we have different events, right? A user joins, maybe other user gets hanged, or he mutes his voice, or he mutes his video like camera, something like that. So I have numerous events in video chat application that I have to receive. So with get session, I can receive those events. So in a video chat, there are multiple users, and every activity of other user is received on a session endpoint. So I can poll on session endpoint to get or listen the events. So these are different types of Janus video room events. Slowly, configure, talking, publishers, leaving, unpublished, WebRTC up. So whenever WebRTC is established, WebRTC up event occurs. So I have to listen that to act on my video chat application. Then if media goes off, then there is media true or false. Then if somebody hang-ups, then I receive hang-up event. So I have to handle these events in my application to show a responsive web application. Otherwise, we have to implement most of those to get video chat working. So let's see how we talk to Janus with Elixir. So we saw a Janus, which is like a C-based web server, but C-based WebRTC gateway server, but we need to talk with Janus. So we can directly do REST APIs, but that's not good, right? We have to write some kind of a Elixir Janus client library. So that's what I did. So initially there was no Elixir Janus client. So in Janus mailing list, I had asked like if there is any existing Elixir Janus client, and there was none. So one of the guy called Nolan Darlick, he said, oh, I had written something with Elixir. So he open sourced the first version. He said, I haven't tested it, but you have to make sure it works, like test it. So I tested it, it was not working, so I had to contribute to get it working. And so this is the GitHub page of that Elixir Janus client. So this is again a simple client where so Elixir Janus client has like HTTP client. Then what we have to do is that we have to maintain state. So Elixir is a immutable programming language, right? So there is no state. So in this Janus client library, I have to add agents to wrap the state. Like we saw, right? Session and plugin. So session has some ID, plugin has some ID. So we have to continuously poll session. So we have to store this ID in memory. So we use agents, and then we have to listen events, right? So for events, Elixir has gen event, and then with gen event we can, like for gen event handlers, we can send events. Like, so in my application, I have multiple handlers where I send the incoming events to those handlers, and those handlers actually respond in the application, and then I react to those like from the
名前書いたのかな。
UI. So this is the structure of Elixir Janus client. So there is session module, then there is plugin module, then there is util module. So this is how it looks. This structure. So the purple, the outside box is Phoenix application, and the pink area is the Elixir Janus client. And you can see there is HTTP module, then there is session module and then plugin module. So session and plugin actually has two things. One is agents, and then there is Gen Event Manager. And plugin also has this thing called state and Gen Event Manager. So state to like capture the IDs, and Gen Event Manager to so that if you attach a handler, Gen Event handler, so that we can notify the Gen Event handler. Handlers from this session module. So I call these session and plugins as agents because these are running in memory whenever Phoenix application is running, and for a user there are always session agent and a plugin agent for a particular user who is connected. Then session Gen Event Handler and plugin Gen Event Handler are the handlers. So these are my application based specific handlers. I have written Gen Event Handler code, and then I accordingly respond from my application. So this is how like Elixir Janus client works in a Phoenix application. And you can see this blue area is Janus WebRTC Gateway Server, which is third-party WebRTC Gateway Server. So let's see the code. So now this is Janus session module. So you can see the struct. This struct has ID, base URL, event manager, and handles. So base URL is the URL to connect to the Janus WebRTC Gateway Server. Event manager is event has this thing called Gen Event Manager. So I store it there. And then handles. So handles are nothing but plugins. For a session, I have multiple plugins, right? Video room plugin, other plugins. So in my application, I have only video room plugins. So there can be more than one video room plugins or handles. So I have this empty map there. And similar to that, I have this module called Janus plugin, where I have similar struct, ID, base URL, and event manager. Again, like event manager to send the events, received events on the plugin endpoint. So basically, now I have this start function where I take the base URL of the third-party Janus server, and then I create the Janus room with the start. So with this function, I can create a Janus room on third-party server, and then I can get the response back. Once I get the response back, I get the ID, I get the session ID. So after that, I start the Gen Event start link, which starts the Gen Event process, and I get the Gen Event Manager back, and then I store this Gen Event Manager in the this struct, right? So I stored ID, I stored the base URL. So base URL here it is this session endpoint URL and event. So event manager to notify the handlers. So we will see how I attach handler in the next slide. So I also have agent here. So because Elixir there is no state, right? There are no objects. So I have to store my this struct into memory. So I use agents to store those values, and I just start the agent, and I return the agent, and I have this PID with me. So similar to start, I have to attach plugin, video room plugin, right? So I created session on third-party media server. So to create video room plugin, like it has to have some, I have to attach on the third-party server. So with this function called attach plugin, I take the original PID and then I do a REST call to the third-party WebRTC gateway server. I get the response back, and then I again do the same thing. I again initialize the Gen Event Manager, and I store this base URL, which is specific to plugin here. So after that, I do some processing. I also update this PID of the plugin into the handles map of the this session agent. So. And there is another API called add handler. So we saw like we can create a session, we can attach plugin, but we have to add handlers, right? So we will start receiving events. So once we start posting the events, right? So the room is created, but if I join the room, if I send the join room HTTP call, I will receive some events from my WebRTC gateway server. So that event should be delegated to some handler. So this add handler function allows me to attach handlers to my this Gen event manager. So so there are two Gen event manager. One is session-based Gen event manager, and there is plugin-based Gen event manager. So I can have like add handler for session, and I can have for plugin also. So that is about like doing the ad handling and creating room, attaching plugin. But now I want to receive events from third-party server. So with the poll function, I actually from my agent I get session back, and from session I have this session base URL for that particular session, and then I can continuously poll that, and I can get data back. So every 1 second I hit the session endpoint URL and I get the data back, and I receive different types of events. So with Gen Event Notify, I actually notify my event, Gen Event handlers, which are like application based. So depending on the response, I do things. So if it is Janus keep alive, you can say I just send Gen Event Notify to just keep alive. But if it has sender, then I check whether sender is plugin or if it is sender is session. Accordingly, I send the I notify the event handlers attached to the particular event manager. It might be sessions event manager, it might be plugins event manager. So this is how this Elixir Janus client works. So this is again the same diagram where I have HTTP util. So HTTP util is to send the post request or get the response like HTTP get. Session and plugin has these agents. Agent has this state and Gen event manager. And then these are the green boxes are the Gen event handlers. So basically, this is the sequence. I start a Janus room with HTTP call. Then I have this init session agent PID, and so once I create a room, I actually like attach plugin, and after that I get this agent PID and plugin PID. I have to store these PIDs to some cache, because I don't have access to those. So for that particular room, I have this cache. I have created this Gen server based cache, and I get the agent PIDs, which is like plugin and session from that cache back, and then I have to use these PIDs to further communicate with the WebRTC gateway server. So for any session related activity, I have to get session related PID back from my cache for that particular room, and then I have to make HTTP call. And then once I do HTTP call, this web server, Janus WebRTC gateway server sends me events, and those events I get in the poll, and I have to act that accordingly to that. So that's it. So problem solved, I get in the poll, and I have to act that accordingly to that. So that's it. So problem solved with Elixir. So we saw now I have Elixir Janus client, and we have a WebRTC gateway server. We have like Elixir and Phoenix. But what are the problems in my application I faced that I solved with this Elixir and Phoenix? So let's see those. So what happened is that in my application, when I implemented, so in a video chat, right, there are multiple users, like there are 3 users, 4 users. Now, let's say one user abruptly closes his browser. So he doesn't click the end button. He actually says, okay, I close my browser, or I crash my computer, or I just turn off my computer. So what happened is that once he stopped his browser or computer, my media server was not aware that he actually closed the session, because agents which are created by Elixir and Phoenix were always running in memory, and those were not getting any information that browser has closed the tab. So what happened is that my media server has this timeout. If it doesn't receive media for 1 minute, it actually kills that session for the user. But for 1 minute, because agents were not doing anything, any activity for that user has gone, media server was not removing those users from other computers. So this is like how it looked. So these are like 3 users chatting in a video chat, and let's say one of those closes the tab. Now, the problem was that for 1 minute in other computers, the user was appearing, and after 1 minute, my media server was removing that. So because I used to get an event from media server after 1 minute, but not immediately. So this was a problem. So I had to solve this, and so how I solved, I use dynamic
そう
supervisors,
なん
gen
だよ
servers,
ね。
and monitors.
ちょっとこれ構成してる、この問題をうまく自分は利用したいなって思ってるんよね。
So let's see how. So when the browser tab was closed, so I start a gen server with the dynamic supervisor, which is running at the application tree, and there is a Phoenix channel. So once the browser tab is closed, Phoenix channel PID is closed. So every browser tab has some Phoenix channel, and it has some PID. And when you close the browser tab, the Phoenix channel PID is getting killed. So what I do is that I have this monitor at the gen server. So this monitor detects that this Phoenix channel PID was killed, and then I have so gen server has this API to like clean up the session agent and plugin agent. So it actually gracefully does cleanup, and then from gen server, as I am monitoring the Phoenix channel close, I receive that down message, and then I do cleanup on the third-party media server. Then a third-party media server receives proper message that this user has actually closed the session, and once I send that data to third-party media server, I kill the agent processes, like both session agent and the plugin agent, and then I also kill the gen server agent process, and then everything is killed, and that user is gone. So this is the code. So you can see this is gen server, and this is gen server API, and so as I said, I have this Phoenix channel which I monitor from my gen server. So you can see there is a channel PID which I pass in the state, and I have this monitor attached, process.monitor, and in the handle info of gen server, whenever there is a Phoenix channel PID kill, I have this down message callback. So I receive this down message callback, and then I do this cleanup. So in cleanup, what I do is that I actually call my third-party media server, WebRTC gateway server, to stop. So here I pass the necessary data, and I also kill the gen server itself. So the video room call dot stop session and handle cleans up the session and handle gracefully, properly. So let's see quick demo. So see this.
Good grammar and spelling are important, but if you want to write essays that inspire...
So this is my application running, and let me close this. So this is running locally on my local machine. Now, so when I start the room, or when I create the room, so I have created room, I haven't joined. When I join the room, so I have joined the room, and I have this observer running. So you can see there is a session agent and plugin agent PIDs. Actually, these are Gen event in this case, and this is like Gen server PID. Now let me start another browser tab. So there are two users now in this video chat, and in this case you can see in the observer you can see these two Gen servers for two users, and then there is Gen there is agent and then is session. Now when I close this browser tab, right? So you can see there are two users, not this one. So there are two users, and now when I close this browser tab, just watch what happens in the other tab. So when I close this, so this user is gone. So initially, when I had not implemented this user used to stay here for 1 minute, and it was not going. But now with this new implementation, where I have these monitors enabled, I can actually close the session gracefully. My media server detects that and removes this user. So this is done with the Elixir and Phoenix. So that was the demo. So let's move. So that was about like how I handled abrupt like tab close or browser tab close. So let's see how. So we know, right? Elixir supports let it crash scenario. So this was not let it crash, right? The first use case was just a case where user had closed his browser. But what if my agent, which is running in the background, gets killed, or if there is a error in the Gen event handler, then my agent might get killed, right? So it happens. Like, so I anticipated that. I didn't require this let it crash scenario, but I thought, like, what if there is an error, or if the third-party media server is down, I might get HTTP error, and with the HTTP error, my agent might get crashed. So that never happened, but I tried doing that, and yes, it happened. So I closed the WebRTC gateway server, and then I saw there is a crash in the agent, and that was not a proper state. So I was not showing any feedback on the browser that this user who is using the application, suddenly there is an error in the background, but user was not seeing that. So he used to continue using the web app, but in the bad state, whether he will get confused. So this is about let it crash scenario. Let's see how I implemented that. So I say, what if this agent crashes? So agent can crash because of HTTP call failure, or it can crash because of Gen event handler's bad code. So there are three users in this video chat, and let's crash in the particular planning one of the planning supervisor has session. Phoenix channel receive Phoenix channel event and chatting with out gets executed. So again, start call.
なるほどね。
Start a Gen server post info call, broadcast the message with stop call.
いろいろ改善の余地がありそう。でもすごくうまいな。
Both are there by multiple. If I kill it, if you see other user, like user, there is no problem. Let's say the user linking video chat. So I command, but stand up update and post it, and this file. So benefits of using feedback like in such an easy manner. very powerful. Like I can't imagine like process-based. The other languages doesn't have any PIDs, something like that. Here you can see, right? I had PIDs, and then I have state. Elixir is built a video chat application with Elixir. So thank you.
いや、素晴らしかった。まあ、自分のやりたいことがなんかすごく詰まってた感じで、やっぱり WebRTC の、フェニックスで WebRTC のサーバーを、作ることと、なんかこう、新しく、この人の取り組みで、やっぱりそれだけだと問題がありで、まあ、クライアントが増えるに続けて、この、まあ、フェニックスサーバーにもすごく負荷がかかっていく。だけど、やっぱそれはあまりにも非効率すぎるものだと。通信的な非効率さが出てくるので、WebRTC のビデオチャットサーバーっていうものを新しく立てましょうっていうやつですね。で、JNAS っていう、オープンソースの、サーバーがあるので、こいつを使いましょう。WebRTC サーバーを立てましょうっていうやつですね。なんか、本当にこれが最適解な気がしてます。ただ、まあ、課題とかもいろいろあったりするので、それは作りながら、やっていこうかなって思いますと。ちょっと集中力が切れてきたので休憩します。では、お疲れ様です。
コネクルさん、お疲れ様でした。